is Unit 8, Lesson 5, video number 2. So in the first video in this lesson, we talked about strong acid-base titrations, and we talked about the 4 stages. Now we are going to look at an example of how we do these problems. So the first thing we have to do is look at the problem and interpret the information. So we have a titration of 25 milliliters of 0.200 molar HCl with 0.125 molar NaOH. So the one that we know the amount or the volume of, this is in the flask, and this is going to be the acid HCl, and we're reacting it with 0.125 molar NaOH, which would be in our burette. We want to find the pH of the solution after the following volumes of NaOH have been added. So this value right here is base. So this is before any base is added. The only substance in the flask is 0.200 molar HCl. So because we have a strong acid and we know it's 0.200 molar HCl, then that means that we have 0.200 molar H3O plus. So pH is derived from the negative log of 0.200 molar, and we get 0.699 as our pH. So that's the first step in any of these problems, is we find the pH of the acid before we add anything to it. Now, you'll see on the next page that we have a variety of additions of our base. And what we have to do is find how much acid or how many moles of acid we have and how many moles of base we add in. So again, these values in here the whole way down are going to be for the base. So we are going to do this step only once, this one that's starred. And this is going to be how much acid is in the flask. So we have to work in terms of moles because we know that the base reacts with the acid in a 1-to-1 mole ratio. So remember when we talked, we said molarity times the number of liters gives us the number of moles using a definition of molarity. So we had 25 milliliters of acid. So that is 0.02500 liters of HCl times its molarity gives us 0.00500 moles of H3O plus, or H plus, either one works. That is going to be what we use for each one of the subsequent values. So now I'm going to calculate how much base was added. So I use the same thing, 0.02000 liters, or 20 milliliters, times the molarity of the base, 0.125 molar, and that gives me 0.00250 moles of OH minus. Now remember, these are in a 1-to-1 mole ratio. This one, the base, is smaller than the acid. So this much base is going to be used up, and it's going to take away an equivalent amount of acid. These are in a 1-to-1 mole ratio. So that means that we can calculate the excess H3O plus present by subtracting. So that's how many moles of H3O plus minus our moles of base, because they're in a 1-to-1 mole ratio, gives us 0.00250 moles of H3O plus left over. And if you want to put left over, that might help. So now we have to calculate the new molarity. But because we added a substance into there and it's a volume, we're going to have a new volume. So we have to calculate the new volume. So we had 0.02500 milliliters plus 0.02000 milliliters. So that gives us 0.04500 milliliters, or liters, sorry, not milliliters, liters. So now we can calculate the new molarity of the acid. So we have 0.00250 moles of H3O plus over 0.04500 liters, which gives us 0.0556 molar H3O plus. We take the negative log of that and we get a pH equal to 1.25. So the pH has gone up from 0.699 to 1.25 even after we added 20 milliliters of base. So our next video is going to look at a couple more of these.